Okay. So parametric equations are xt equals set. The value of x numbers, function of t, following this one, e to the t. xt, the graph of this one, if this is t, this is xt, okay? Yeah. X is what? Et. So actually t is independent variable. X is now still dependent variable, okay? It depends on the value of t. Yt is t. This is yt is what? Follow this t. Okay? This is y equals t. So which of the following could be graph of y equal f of x? Now we need to find the graph between x and y, not without t. So we have a parametric equations. If you eliminate the variable t, which is what parameter? T is we set parameter, okay? From here, t is we set parameter. Okay? When you take about parameter, just find out the direct relations between x and y, you'll get the graph over here, right? This is the x and y graph. So how can you eliminate the t? T equals y over here. It's already there. But this is t up there. Okay? So I'm going to write down one more time over here, okay? xt equals to e to the t. We know that t equals yt. This is t equals y. Replace with y. When you got this one now, no more t, right? T is out. E to the what? Y, isn't it? We just eliminate, right, the parameter t. Okay. So what is this graph? Y equals, because this is the y equals, what is it? ln x graph. Are you okay with this?
Yeah.
Because that is equivalent, right? You know that y equals actually, this one equals y equals log e to the x. But log e, that is ln x, okay? Still log graph. Which one graph represent a log? This one, right? This is exponent. This is log graph. Are you okay with this?
Yeah.
So choice E is the answer, okay?
Yeah.
We have a number 8. If the function f defined by f of x equals e to the what? 2x minus 1 and g of x is inverse function of f. So g of x, this one is exactly equals to f inverse of x. Okay, we did this many times. G prime, that is what? The slope of tangent of E at x equals E, right? That's the meaning. Yeah. It's okay. So maybe we can find their inverse. You don't have to solve it this way, okay? Maybe either we can find the inverse anyway. So f of x is what? To find the inverse, that it take y equals e to the what? 2x minus 1. After that, you can switch x and y. That's the inverse, okay? The step 1 is what? Switch x and y. So this is x, e to the 2y minus 1, okay? Now we need to express y in terms of x. 2y minus 1 equals what? Log e to the x is y, ln x. So 2y equals plus 1 plus 1, 1 plus ln x. And divided by 2 is what is there? 1 plus ln x. And divided by 2, this is what? F inverse of this one. Or you can use the gx that led this way. Are you okay with this? Because this one is, we can, easily you can find the inverse, okay? But sometimes it's very hard to find the inverse in algebraically. At that time, so we have to use the other method, okay? But this is okay. You can find the inverse over here, right? From here, what is that? G prime 1. G prime E, X is E. That's right?
Yeah.
Okay. So take them out to G prime X, okay? G prime X, what is that? 1 over 2 plus ln X, okay? So 1 over 2 is a constant, that is 0. ln X is what? 1 over 2 times ln X is what? Derivative 1 over X, right?
Yeah.
So that is 1 over 2X is the derivative of G of X. It's the inverse of f of X. Now put this number E there. Now G prime E, that is that equals to 1 over 2E, right? We have the answer over here. Now, second case, when we have a difficulty to find the inverse. So we have to use other method, which is what? The formula, okay? For examples, this is the original f of x. Y equals f of x. Inverse always was symmetry in the y-axis, okay? This is inverse, y equals f of minus x, or that is g of x, okay? Now we need to find the G prime. G prime is what? Slope of tangent of G at x equal E, right? At x equal E, what is the slope? So that's the slope is what? This one, right?
Yeah.
This is the tangent line. Slope of this tangent slope of the tangent, that is what G prime E at x equal E, okay? So now take this one is what I'm going to use some value of A, okay?
Yeah.
So we have corresponding point on this one on the other original point. A and E always perpendicular this way. There is, switch this one, right? A and E. That's the corresponding point on original graph, okay? But between these two corresponding points, there is a very interesting formula, right? What is the formula? G prime first. G prime E, this is exactly equals, at this point, we have another slope of a tangent line, okay? That is this slope of a tangent line is what? F prime A, isn't it?
Yeah.
Okay, so on the same corresponding point, okay, each slope of tangent is what? G prime E, the other one is F prime A. Okay, the relationship G prime E is what? Always reciprocal of F prime A, okay?
Yeah.
That's the formula, isn't it?
Yeah.
Now let's find this one first. Because what sometimes we think it's fine to find the inverse is a little hard, okay? Then better use this method. So what is F prime? When X is A, what is E? Okay, using this one, we can find the value of A, right? Because A is unknown numbers. So when X is A, over here, okay? Y is E. So from here, we can find E equals E to the X is A, 2A minus 1, isn't it? From here, 2A minus 1 equals how much? Over here, right? 1, okay? Are you okay with this?
Yes.
E to the 1 equals E to the 2A minus 1. The same base number, 2A minus 1 is 1, 2A is 2, A equals 1, right?
Yes.
This point is now A and 1, okay? This point is now E and no. A 1. First one is 1. 1 and E. This point is E and 1, right? Switch.
Yes.
So now let's find F prime X, okay? So from here we can find F prime X. F prime X is what? Take a derivative. e to the 2x minus 1 and times its derivative of 2x minus 1, which is 2.
Yeah.
Okay. Now put this number now, a is 1, right? So f prime 1 is how much? E to the what? 2 times 1 minus 1 is 1, right? So that is 2e. Put this number there. So finally, this one, g prime e equals to what is it? 1 over 2e, right? F prime is 2e, so 1 over 2e. It's going to have the same numbers over here, okay? Okay. If you can find the inverse, you can go this way. It's okay too. But you think it's hard to find the inverse, you better go this way, okay? Second method. Are you okay with this?
Yeah.
This is the formula, okay? Okay, the last times we did the number 9, but we're gonna try again, okay? So let me take them out. What is the equation of the line tangent to the graph of y equals arctangent x at x equal 1? You know what is the arctangent x? Do you remember? Okay, I'm showing the graph over here, okay? Y equals arctangent x. That's the arctangent x. Can you see it over here?
Yeah.
This one is a pi over 2. I'm going to write down over here, okay? Asymptote is a pi over 2. I over 2 over here. Okay, that is asymptote. The bottom here over here, negative pi over 2, right?
Yeah.
That's right. Yeah, that is it. But we're gonna find what? The equation of a line tangent to this graph at x equal 1. Where is x equal here? Can you start at x equal 1? You can make a right graph, right? The tangent of line, okay, at this point, x equal 1 over here, okay? That is 1. Move. That is 1. Actually, the value of y is pi over 4, okay? You understand this graph?
Yeah.
Arctangent, symmetry, okay? This is the graph over pi, negative pi over 2. Positive pi over 2. This is the graph of tangent x. Arctangent is why its inverse must be reciprocal on this line, okay? Y equal x. Are you okay with this?
Yeah.
So this one is a domain over here, negative pi over 2. Now I'm going to change this one, range is a pi over 2. The graph, right, its inverse graph looks like this way. Okay? So we have a point over here. This point, actually, we did already 1 and pi over 4. At this point, we're going to find the line of tangent. Okay? So we're going to find the equation of this line. Anyway, we need to find the slope at this point, x to 1, y to pi over 4. Okay, we need to find the slope of this one, okay? Okay, how can you find the slope of here? Derivative at x equal 1, right? So dy dx, arctangent x derivative, what is that? 1 over 1 plus x squared, isn't it? Are you okay with this? All right, so f prime, when x equals 1, the slope is about 1 over 1 plus 1 square is 2, right? Slope of this line of tangent is 1/2. And this point, when x is 1, we need a point, right? Because to find the equation of tangent line, we need a slope and a point. We got the slope already over here. And we need a point over here, 1 and pi over 4. But this one, we got this pi over 4 on the graph. Okay, without graph, how can you find these numbers? Put this number x is 1 in the y, okay? Y equals arctangent, I'm going to use these symbols. Arctangent, okay, when x is 1, what is y? Arctangent, that is equivalent this one. This is take y, okay? So that means equivalent. Tangent y equals 1. Are you okay with this? Tangent y equals 1 is a positive over here, right? For what value of y angle, that is 1. This is what? 1. Tangent 1 is a 1 over 1 is a tangent, right? So the value of y is what? Pi over 4, 45 degrees, isn't it?
Yeah.
Because we know that tangent 45, which is a pi over 4 is 1. So the angle must be equals pi over 4. That is the value of y. So y is what? Pi over 4 there. Now we got the slope and a point. Use was point slope of y minus y1. Y minus y1 is a pi over 4. Slope is 1 over 2 times x minus x1 is 1. That's the equation of line tangent. Okay. So we already there. So y equals pi over 4, 1 over 2x minus 1. Choice C is the answer. Okay. Are you okay with this?
Yeah.
All right. Number 10 there. I'm going to take this one out. Number 10. The function f defined by f of x equals 1 over 4, x4, and 2x squared plus 2. Which of the following is true about at x equals 1? Okay. Good. So increasing, maximum, minimum, or discontinuous concave down, we need to find what? First derivative and second derivative, right? Check it out, first derivative first. F prime x. This 4 moved to the front 1 x cubed and minus 4x, that's it. That's the first derivative. Check it out over here. First derivative is increasing, decreasing is about first derivative, okay? Now put this number x is 1 there. From here, f prime 1. F prime 1 is 1 minus 4 is negative 3. At x equals 1, that is the slope is negative 3, means the graph is what? Less than 0, right? Okay. Graph is what? Decreasing. Are you okay with this? Not less than 0, okay. This is a slope. At this point, x equals 1, that is a negative. Okay, that is a negative number. Okay, first derivative is negative means what? Graph is decreasing, not increasing, okay? Graph is decreasing. So this is not correct. Second one is f has a relative maximum. Okay, f has, how to take a relative maximum? When you take this is 0, x squared plus 4 equals 0. This is what is there? X times x plus 2, x minus 2 equals 0. Okay. If this x equals 1, that is the relative maximum. this is the stationary point, critical point over here. 2, 0, and negative 2, right? When you make a graph of f prime x, graph looks like this way. This is increasing, this is graph of f prime x, increasing, decreasing, increasing, decreasing. It has a relative maximum at this x equal 2, right? Not x equal 1. It has a relative minimum at x equal 0. That is your relative minimum. This point is our relative maximum. This is also what? I'm sorry. Oh, well, this is minus, okay. Minus plus, oh, minus plus, what I'm doing there. That is the relative minimum, okay? This one at x equals negative 2, relative minimum. At x equals 0, relative maximum.
Yeah.
Relative minimum again, okay? At x equals 1 over here, nothing, right? There is no relative maximum minimum, right? This is both to wrong at x equals 1, okay?
Yeah.
Okay, at x equals 1, there is discontinuous. No, this is right. The derivative, no undefined one there. Okay, so they are all continuous, right? But this is wrong too. F is concave downward. We're gonna check it out. Concave down is we have to take right second derivative. Okay, first this one is our first derivative test. The last one is we need the second derivative. Okay, what is the second derivative? F second derivative x. Take this one. First derivative already. Take the derivative one more times of first one. X cubed is what? 3x squared.
Yeah.
And minus 4. Okay, so check it out at x equal 1. Okay, at x equal 1. F of prime 1, that is what? 3 minus 4, which is a negative 1. That is less than 0, right?
Yeah.
Second prime at x equal 1 is less than 0, means that the graph of f when x equals 1, that is concave down, right? Concave down, that is true. Okay, that is concave down. At x equals 1. Are you okay with this?
Yeah.
I'm going to show you the graph over here, okay? Y equals to 1 over 4. X to the 4. Minus 2 x squared. And plus 2. That's the graph over here. You can see the graph. Okay. We are talking about at x equal 1 here, this point. At x equal 1. Okay. Okay, anyway, around over here at x equal 1. This graph is increasing, at x equal 1, there is a decreasing, right?
Yeah.
Okay with this? At this point. At this point, there is decreasing. Is this a relative maximum? No, this one. At x equal 0, there is a relative maximum over here. At x equal negative 2, relative minimum over here. X equal 2, relative minimum. X equal 1, nothing, okay? There is no relative maximum or minimum. Is this continuous? No, that's continuous. This is concave down over here. Is this concave down? How to think? This is concave up over here. Okay? but some over here still concave down up to here. Okay, this is the graph, right? So after 0 over here, that is concave up, right? From here, that is concave up. Do you understand this one?
Yeah.
So to make a 0 over here, this graph looks like this one. Okay.
Yeah.
So to find the inflection point, you make a 0 here, okay? 3x squared pro is 0, x squared is what is that? 4/3. So x is around what, 1 point, something like that, okay? A little greater one. After this, okay? From here, they're gonna write concave up over here, okay? This point is what, inflection point. Concave up here. Up to here, that is a concave down, okay? That is a concave down. This is concave down, okay? So x equal 1 over here, okay? Still concave down over here, right? Graph looks this way. Okay? So choice E is the answer, okay? Choice E is the answer. Number 11, derivative of 2x plus 3x. Can you try this one by yourself? Do you remember the derivative of exponential functions, which is a base number E, or some other times
We bring it to
base
the front,
different?
Ellen, and we can bring it to the front. Bring it down. Once we do that.
What? So, okay, can you try number 11?
Yeah.
Derivative of 2e to the x. Derivative e to the still e to the x, right? It doesn't change.
Yeah.
Okay, we work together. Still e to the x. This is not e, okay? Different, right? Derivative of 3 to the x is what? 3 to the x, but we multiply it what? ln the base number 3, right? By this case, this is the formula when you have an exponential function. The number and multiply to ln the base number e. When you have a right e to the x base number, ln e is 1. That's why e to the x, e to the x, same numbers. Are you okay this?
Yeah.
But this is not e, so we multiply by ln 3. Is it okay? So e to the x times 3 to the x and ln 3 is the answer, okay? Choice E is the answer. That's the derivative. Are you okay with this?
Yeah.
E to the x, derivative is e to the x, because why? ln e is 1. But a to the x, which is not equal to e, this same is this one, ax, but this is the ln a, but ln a is not 1, okay? Just you multiply by ln a. That is different. All right, number 12, are the region enclosed by the graph y equals sine pi x? Okay, we're gonna find the area of said region. Sine pi x, can you make a graph sine pi x?
That starts at the 0.
We start from here, right?
Starts at the 0 and it goes up by each increment. So half over pi over 2, then pi, then 2 pi eventually at the end of it.
Okay,
Starts
that
at
the
the-
frequency is pi, right? Frequency is pi. The period is how much? 2
Oh, yeah,
pi
okay, sorry.
over pi frequency 2.
Mm.
In 2 over here, I'm sorry, period is 2. The graph looks this way. This is 2, okay? Are you okay with this?
Yeah.
Right. Y is 2. Where is Y is 2? This is 1, right? Y is 2 up here, twice. This is Y is 2. Are you okay with this? Where is X is 1? This is X is 1, right? Half of this is 2, that is X is 1.
Yeah.
So where is the area? This is there enclosed by Y is 2, X is 1, and Y equal sine X. Oops. And the y-axis. Oh, we have a y-axis over here. So this is the y-axis. No, this is not y-axis, right? Oh, this is y-axis. That's correct. Or closed. That's fine. So this is the area. Okay. So where's the upper graph? Y equal 2 is upper graph. Higher graph over here, right? We take up this one at the bottom, that is the lower graph. So it got what? Shaded region. Are you okay with this? We take integral, okay, from 0 to 1 over here, okay? This is the length. This is length from here to here, okay? We're gonna take this length from 0 to 1, that is the area, okay? So you can take this one. 0 to 1 there. Upper graph is y equal 2 minus lower one is y equals sine pi x. We take this one, integral from 0 to 1, that's the area, okay? That's it. What is the antiderivative over 2? 2x. What is the antiderivative of sine pi x?
2x sine pi x.
Sine pi is what? Antiderivative is what? Cosine pi x. But there is a pi there. We're going to divide it by pi, okay?
Don't you add the one? Oh, wait, no.
And the 0 to 1, okay?
Okay.
Now put this number, x is 1 there. This is 2 times 1 is 2 plus cosine, x is 1 cosine pi over pi. That's the first one. Second one is minus 0. X is 0, that is 0. Second is what? Cosine 0, okay? Over pi. That's it. Now take about this one. Cosine pi, do we know that negative 1, right? Okay, cosine pi is negative 1. So 2 plus 2 minus 1 over pi. That's the first one. Second one is 0 minus cosine 0 is 1. So 1 over pi, okay? We don't need the price, it's just 1. 1 over pi. So 2 minus 1 over pi, another negative 1 over pi is what? 2 minus 2 over pi. Are you okay with this?
Yeah.
2 minus 2. Two minus 2 over pi. Oh, okay. We just simplify, okay? So put this number pi there, okay? 2 pi over pi, right? This is 2 pi over pi, which equals what? 2 pi minus 2 over pi, okay? Yeah, we got the answer there. Okay, this length equals to y is 2 minus sine pi x, okay? That's the length of it, okay? We take this length with take integral from 0 to 1. That is the area, right? Okay, that's it. Number 13, if a parametric equations, xt is what square root 2t minus 1 and yt is 2t, you're gonna find the dy dx. Okay, there's no t there, right? Okay,
Yeah.
so dy dx, or you can express y in terms of x. You can do that, but it takes time. Anyway, later we can try it, okay, with that method. But over here, this is our general approach. dy dx. dy dx, you can divide by dt, right?
Yeah.
That is exactly equals to dy dx, same thing, okay? Are you okay with this?
Yeah.
Now let's find out dy dt first. dy dt, how much? 2, right?
Yeah.
dx dt. dx dt, this is what 2t minus 1 and 1/2. 1/2 move to the front and 2t minus 1 and the minus 1 there, that is a negative. But 1/2 take derivative inside times 2. So this is out. Looks like right there. 1 over square root 2t minus 1. Okay, that is dx dt. Okay, now you can use this one. dy dt is 2. dx dt is what? 1 over square root 2t minus 1. Okay, but we're going to solve this one in terms of x. Okay, so what is t? T in terms of x. Can you find the formula? T is what in terms of x. This is a little bit more work, right? This is in terms of t, but we need to find in terms of x. So xt, x equals what it is? Formula, right? X equals square root 2t minus 1. When you make a square, we got this one. X squared is what? 2t minus 1, right? So x squared plus 1 equals 2t. So t equals what? X squared plus 1 over 2, right? That is t. Are you okay with this?
Yeah.
Now, put this number, this one is exactly how much? 2 times square root 2t minus 1, right? Okay. Yeah. Oh, we don't have to, right? Square root 2t minus 1, that is x. This is x, okay? We don't need this one, okay? That is already why x equals square root 2t. So replace with x, okay? Because square root 2t minus 1 is the x, so this is equals to 2x. Are you okay with this?
Yeah.
Okay. Now, second one is that's can you find dy dx in terms of x? We just eliminate, right, the value of parameter t, okay? Take it over here. 2t equals y. So xt, now t is out. X equals 2t, that is y, okay? That is equals to what is that? 2, that is y minus 1. Are you okay with this?
Yeah.
That is 2t, that is y. Okay. Now we're going to find the dy dx. Okay, make a square there. Just x squared is what? Y minus 1. From here, y equals how much? X squared plus 1 there, okay? Now, can you find from your dy dx? That is 2x, right?
Yeah.
You can solve this way too. Because that's when you find, okay, the derivative dy dx in terms of x. If they want you leave, right, the parameter t, you can use this one, okay? That is number 13. Number 14, okay, we try this one more time, okay? We did the last times. Find the equation of normal. You know the normal, right? Normal is what? Perpendicular to the tangent line at point, okay? So when you have a log
At a certain point.
Excuse me?
At a certain point. Do they give you a point?
Yeah, that's the point of it, right? At x equal e, okay?
Okay.
At x equal e, what is the y? Okay, you can continue to find the point first. When x is e, y equals y, ln e, right? X is e. ln e is what? 1, isn't it? The point is what? X is e, y is 1. That's the point. So the graph over here, ln x graph looks like this one. Okay? When this is e, this point is what? E and height is 1. Okay? That's the graph. We're going to find the equation of this tangent, but normal is what? Perpendicular to this tangent, same point. This is what? Normal.
Yeah.
Okay, this is tangent. This is normal. By the way, it has right the point 2 and 1, okay? Because tangent normal, they are perpendicular. Okay, now let's find the slope of tangent. Okay.
Yeah.
dy dx. 1 over x. That's right. At point E, x is E. Slope of this tangent is how much? 1 over E. Are you okay with this?
Yeah.
Okay. So what is the slope of this normal? Slope of this normal is how much? Negative reciprocal, right? That is a negative E. Are you okay with this?
Yeah.
Negative reciprocal of this one, right? Negative E. Now we have a point E minus 1 using point slope first. Y minus y1 is 1. Slope is a negative E and x minus E. Okay, that's the equations. Point slope. Now express y plus 1 there. Negative e to the x, negative ex, negative times negative e is what? Positive e squared, and over here plus 1 there. That's the equations. Negative ex plus e squared plus 1, okay? That's the equation of this normal. It's okay, right?
Yeah.
All right, number 15, 0 to the 4, okay? We need to find the antiderivative of this one. How can you find the antiderivative of this one? This one is a little hard, but you can do that. X squared minus 4x plus 4. What is this one? That is x minus 2 squared, right? You can factor this one.
Okay.
X minus 2 squared is what is that? Equivalent. Always x minus 2 absolute value, that is equivalent. Are you okay with this? But x minus 2 graph is over here. Turning point is x equal to y equal 0, okay? X minus, this is x minus 2 graph. Now we're gonna find the 0 to 4 here. Area of this one. But this area and the other area is gonna have the same slope to the right-hand side of absolute, to the right, left, they are same slope, same base number 2. It's gonna have the same triangle which are congruent. You can find the area on this graph too. When x equals 0, y is 2, right?
Yeah.
What is the area of this one? 2 times 2 and divided by 2 is what? 2, right? We have a 2. The other one also what? Area is 2. Total area of this one is 4, right? If not, because we have a 0 to 4, that is the absolute value. From 0 to 2, that is what is that? 0 to 2, that is negative, right? So this one is equals to how much? Separate 0 to 2, algebraic, okay? This one is inside the number is a negative number. To make a positive, we need one more negative sign. Negative x plus 2 dx. And plus 2 to 4, that is a positive unit absolute value, x minus 2 dx. Okay? You can take an integral both to integral, okay?
Yeah.
It's gonna have the same numbers. Negative x is what? Negative x squared over 2 plus 2x. From 0 to 2. This one is what? X squared over 2 minus 2x. 2 to 4. Okay, when you take this one, this is a 2, this one is a 2, okay? Total is a 4, okay? But in this case, if you understand the meaning of this integral, okay, you can find the graph from the graph, okay? You can find the right area from the graph. Number 16, function f defined by f of x equal 3 cosine x minus 3 sine x. What is its amplitude of f prime? It's memorized, okay? We have a cosine and sine is amplitude. Amplitude always was square root. This amplitude square, the other amplitude square, okay? That is equals to what? Square root 9 plus 16 equals to 5, okay? Square root 25 is 5. Are you okay with this? Because cosine x, sine x is always a pi over 2 difference. This sine over 2 over here. Cosine is over here. Okay? This is a 3, sine is a 4, this is 3. This one is amplitude, okay? Always. Amplitude of these two combined, sine and cosine, always what? Square root, each amplitude, okay? 3 square plus 4 square equals to 5, okay? Just memorize this one, okay? Because I'm going to show you the graph of it. Y equal 3 cosine x. This is 3 cosine x. And y equals negative 4 sine x. Okay. When you add this one, let's see, okay, what happens, okay? This is each graph. One is the cosine x, the other is the negative. When you add these two, it looks like this one. Y equals 3 cosine x minus 4 sine x. Is it over here?
Yeah.
New graph over here. When you add this one. When you add this one from here, this point is what? Highest point. That is the amplitude, right? 5. Bottom is negative 5, okay? That is the amplitude. Are you okay with this? So this 5 is what? This one is 3, this is a 4. when you make a Pythagorean theorem, 3 square plus 4 square, it gives us what? This 5, okay?
Yeah.
Okay, that is what? 5, okay? That's right. Okay, try number 17. Over 3 to the 4, we take an integral 1 over x minus 1, x minus 2 dx. This one is we set partial fraction, okay?
Yeah.
1 over x minus 1, x minus 2, that is separate with what? A over x minus 1, b over x minus 2. Now simplify this one first. This one is what? X minus 1, x minus 2. This is a common denominator. We multiply x minus to the a, multiply x minus 1 to the b. That is equals to 1 over x minus 1, x minus 2. Denominator equal, numerator should be equal. So 1 equals, should be equals a x minus 2 plus b x minus 1. Now we can decide the value of a and b. We have two special values there, okay? X is 2, x is 1. To make a 0 here, okay? Put this number x is 2 first. When x is 2, left hand still is 1. X is 2 is what? That is 0. B minus 2 minus 1 is what? The value of b is 1, right? When x is 1 there, put this number 1 there. This is 1, this is 1, that is 0. First one is 8 times. 1 minus 2 is what? Negative 1. From here, a equals negative 1. So a equals negative 1, b equals 1. So this one is exactly equals to negative 1 over x minus 1 plus 1 over x minus 2. Now this is integral 3 and 4. Negative 1, I'm going to write down this first. 1 over x minus 2 minus 1 over x minus 1 and dx. Same thing. 1 over x minus 2 is what? ln x minus 2, right?
Yeah.
Because there is a 3 and 4, both numbers are positive. We don't need the absolute value, right? 3 and 4, but you can use the absolute value, it doesn't matter. Minus ln x minus 1. We take integral from 3 to the 4. Over there, ln 4 minus 2 is 2, right? We don't need the absolute value. That is a positive, right? ln 2 minus ln 4 minus 1 is 3, that is ln 3. Put this number 3 there. ln 3 minus 2 is 1. ln 3 minus 2 is what? ln 2. ln 1 equals 0. So that's going to be equals ln 2 minus ln 3. This is 0. Minus is plus ln 2. So that is equals to ln 2 and minus ln 3, okay? But we don't have answer there. That's just simplify. This 2 is moved to the back over here. That is 2 square. That is ln 4 minus ln 3. That is a subtraction. When you put this number together, that is a quotient. That is find equals by ln 4 over 3. 4 over 3, okay? You understand, okay?
Yeah.
Log A, log B, that is log A over B. ln is same things, ln A, ln B, ln A over B. Okay? Now we got the answer ln 4 over 3, okay? 4 over 3 there. That is number 17. Number 18, the graph of f prime, the derivative of f is shown in the graph over here. This is the graph of y equals f prime x. Not original, okay? That is f prime x. Which of the following true about graph f? We are talking about the graph of f, original graph at x equals 0. F is not differentiable at x equals 0? No, at x equals 0, the value of y, f prime, y is 0. That is differentiable. That is not original graph. Okay, if we have this original, that is not differentiable, right? This is a graph of f prime. F prime at x equals 0, y equals 0, right?
Yeah.
There is a slope is 0. Not differentiable? No, this is the first. Differentiable, right? Which is f prime 0 is 0. A point of inflection at x equals 0. Take a point of inflection is what? Second derivative. We have a first derivative there. So derivative of first derivative is there, second derivative. Okay, second derivative is 0.
Yeah.
Oh, let's take or undefined one, okay? Or undefined, the same thing, or undefined. Like we're gonna check it out. They are change concavity, right? Slope of first derivative is a second derivative. That the slope is negative. That is a concave down before 0, right? Concave down. Right after this, they change their slope is a positive. That is concave up, right?
Yeah.
Or at this point, they change their concavities. That's why this is what? Point of inflection.
Yeah.
Now we continue, check it out, okay, why it's wrong there. F is discontinuous at x equals 0? No, at x equals 0, we have a derivative. That is what? Continuous. Okay, that is continuous. F has a relative maximum at x equals 0? No, that is what? Positive, positive, increase, increase again. Okay, increase, increase again. Right, that is not relative minimum. Relative minimum is what? Decreasing, increasing, right?
Yeah.
And the limit f of x does not exist. F prime x limit is what? That is continuous, right? Okay, derivative is just over here. That means what? There is a limit value. Okay. Yes. There is just right the value of this one. Okay. When x close 0, so f of 0, that is a limit value. Are you okay with this?
Yeah.
F of 0 is a continuous. Okay. Because what? F prime 0 is 0. We're gonna make a graph of this one. Okay. For examples. This is the graph over here. This is the graph of y equals f prime x. And we're gonna make another graph on the same over here, okay? If somewhere over here, x, this is y. We're gonna find the graph of f of x, that original graph. This is concave down, right? Slope is negative, which try, okay? At this point, any point is okay. From here up to here, we check out. That is positive, is increasing, okay? That is increasing. First derivative increasing, second also increasing. Increasing, but slope is negative, but that means concave down, right? Concave down increasing, the graph looks like this way. Concave down increasing, the graph looks this way. Okay, concave down increasing, right?
Yeah.
The second one over here, still positive, that is increasing too. What's the slope over here? Positive, that is concave up, right? Still increasing concave up. Looks like this way. Are you okay with this? This is the graph. Okay.
Okay.
As you go to 0, there is what? Continuous, right? Because what? X equals the slope is derivative is 0. The line of tangent at x equals this point, 0, right? There is tangent line over here. Okay. Actually, this graph looks like this one. This graph is what? X to the what? 2/3 graph. Its integration, how much? +1. So integral y, this original graph, y equals x to the 2/3 derivative, right? That is the original graph, okay? This original equals, looks like so +1 is 5/2, x to the 5/2. This was 2/5 graph. Plus c, I'm going to take up c equals 0, okay, in case. I'm going to make a graph of this one, okay? This graph derivative is this one. Take a look over here, okay? Y equals 2/5. Y equals 2/5, x to the what? 5/2. +1, 3/5, okay, yeah. 5/3. Can you see the graph over here?
Yeah.
Okay, that is 5/3. That's it, right? Can you see very similar, right? From here to here and here. Up to here, that is what? Concave down, right? Increasing concave down. From here, increasing concave up, right? Now I'm going to put this one over here. It's a derivative over this derivative, right? X to the 2/3. Y equals x to the what? 2/3. X to the 2/3. Take a look. This is derivative functions. At this point, it was still 0 over here, okay?
Yeah.
This is the graph. Are you okay with this?
Yeah.
Okay. Okay. So limit value f of 0 exists, right? That's continuous because the derivative exists, okay? The derivative exists. Number 19. The position of a particle on the x-axis at time t is given by the equation xt equals at t squared plus t. What is total distance? They're asking you a total distance, not position, right? Total distance traveled by 0 to 5. This is a position, so we have to check it out, okay? When they move to the right, move to the left, okay? Position is what, plus minus, okay? But we're gonna find all travel distance. So to the right, to the left, we're gonna find, okay, when they're changed by their directions. F prime t, that is a derivative. Take a look, derivative, 8 minus 2t. Okay. So to make equal 0, t equals 4, isn't it? Or you can make like factors. 4, negative 2 is okay. 4 is out. 2 is out, okay. 4 minus t. Okay. So derivative, when t is less than 4, all right, that is what? Positive, right? This is the graph look at positive. Okay,
Yeah, it's
that is a positive, negative. That means what? Up to from 0 to 4,
positive.
from here, from 0 to 4, move to the
Positive.
right. Yeah, move to the right? After 4 to 5, 4 to 5, move to the left. Travel distance, we're gonna add all these lengths, okay? So we're gonna separate. To the right is a 0 to the 4, that is about positive.
Yeah.
Acceleration, okay? So how can you find this one? We have already position function there. When x is 4, we can find the positions. When x equals 0, we can find the positions. Okay, so there are difference with travel distance. So travel distance from to the right, Okay, to the right. To the right, travel distance. Equals what? X to the 4, when x is 4, when x is 0, okay? Minus. When x is 4 is how much? 8 times 4 is 32. 4 squared is 16, and plus 2. And x0 is 002, which is 34 minus 16, that is 18, and minus is 16, right? They travel distance to the right by 16. To the left, okay? When x is 5, to the left. X equals 5 minus x to the 4, right? That is move to the left. X is 5, how much? 8 times 5 is 40, and minus 25, and plus 2. And x to the 4 is how much? Over here, we already got the 16, right?
Yeah.
I'm sorry, x to the 4 here, that is 18, right? Minus 18.
Yeah.
So 40 minus 25 is 15, okay? 17 minus 18 is negative 1, right? Negative 1 to the left by 1. Anyway, distance is still 1. Are you okay with this?
Yeah.
We need to find the absolute value, okay? That is the distance. Equals to 1 there, okay? Absolute value. So total distance is 16 plus 1, right? 17 is the answer. The total travel distance.
Yeah. Wait, how come we did 34 minus the 16 to get 18?
X to the 4 over here, right?
Yeah.
Put this number x to the 4, that is 18, okay? X to the 5, this is x to the 5, this is x to the 4, okay? I'm going to write down over here. We did already x to the 4, we can calculate already the 18s. X to 5, we calculate over here, okay? Put this number t is 5 in there. All right, number 20, which of the following functions are differentiable for all real value of x? Differentiable, right?
Yeah.
What about number 1? Differentiable. But also you can find this one on the graph. Y equals to x to the 2/3 graph, always this one. This is original, okay? But at this point, not differentiable, right? Okay, that's what? Cuspo, isn't it?
Yeah.
So try this one, dy dx. dy dx is what? 2/3 move to the out. X times what? -1/3. What this one? 2/3 x to the what? 1/3, isn't it? Try this one, x equals 0. At x equals 0, 2/0 is undefined one, right?
Yeah.
Or dy dx at x equals 0, 2/0, that is undefined. That's not, this is not differentiable, okay? Y equals 1/3. 1/3 graph looks like this way. Yeah, that's no that's smooth, right? Okay, that is what? Differentiable, right? Take this one, dy dx. 1/3 move to front, x to the what? -1, -2/3. Okay. So 1/3 up here, 1/3 to the x to 2/3. Oh, still x equals 0, that is undefined one, right? Okay. Yeah, still this is undefined one. Yeah, when x equals 0 over here, that is undefined. Y equals x minus 1. Y equals x minus 1 over here, 1. That's the graph. This is a sharp corner still not differentiable, right?
Yeah.
So this point, at this one point, they are not all differentiable. So which one is differentiable there? Or real value of x? This
Yeah.
point, no. This point, no. This point, no, right? So none is the answer, okay?
Okay. Yeah.
So all these three graphs, okay, not differentiable at one point. X equals 1, 0, 0, and the last one is 1 over here, okay?
Okay.
Number 21, we have f of x. Take a derivative at x equals 1, okay? We need to find the derivative, which is the slope of tangent at x equals 1. Can you take derivative over here? But that is very complicated. Right? Very complicated, right?
Yeah.
Okay. So when you have this one to combine this, you can use, okay, this one you can take a log and then f of x. Okay. Put this number ln. There is what? X to the 6 minus, okay. Square root 2x minus 1 over x plus 1 n squared.
Yeah.
When you take ln, that is why multiplication is addition, division is what? Subtraction, right? So that is actually ln x to the 6 plus ln square root 2x plus 1 n minus ln x plus 1 n squared, right? Plus minus separate. Finally, continue over here. 6 move to the left. Okay, so 6 ln x. This is 1 over 2 move to the front. 1 over 2 ln 2x minus 1.
Yeah.
And the minus 2 is going down to ln x plus 1. Very simplified, okay? Now take a derivative. What is ln f derivative? Fx over f prime x, isn't it?
Yeah.
You remember? Ln u prime is what? U over u prime, right? So f
Yeah.
over f prime. Now take a derivative of ln x 6 times 1 over x. 1 over 2 times, this is derivative is how much?
Whenever, wait.
2x minus
no,
1 over 2, right?
Um,
The function and derivative of 2x minus 1 is 2.
okay.
The next one is 2. This is x plus 1. Derivative of this is still 1, okay? Now this is out. Now put this number x is 1 there, okay? So actually f prime x, I'm gonna put prime x is 1 there. So f prime 1, we're gonna find f prime 1, right? F prime 1 over f1, that is equals to how much? 6 times x is 1 is 1. This is 1 over 2 times 1 minus 1 over 1, right?
Yep.
It's okay? 2 minus 1 is 1 over 1, and the minus 2 is what? 1 over 2, right? So this is what? This is out. That is equals to 6. F prime 1 over f1 equals 6. So f prime from here, f prime 1 is how much? 6 times f over 1, right?
Yeah.
To make it simplify, we use the log, okay?
Yeah.
So f over 1 is how much? We're gonna find the f over 1 there, okay? From here, we can find f over 1 there. How much? F over 1. Just number 1 there, 1. This is inside the 2 minus 1 is 1 or 1, right? The bottom is 1 is 1 plus 1 is 2 squared is 4, okay? 1 over 4. F of 1 is 1 over 4. So this will equals to what? F of prime is just 6 times 1 over 4, okay? That is 3 over 2 is there, okay? Are you okay with this?
Yeah.
Okay. Okay. Okay, we continue to work next time, okay? Today, January 4th, up to 2023, okay? Maybe next time we can finish all this multiple choice, okay? I'm gonna put this, I'm gonna post right this video on YouTube, okay? You can take a look. I'm gonna send out the link, okay?
Thank you.
All right, and also I send out today's work, okay? Okay,
Yeah.
I'll see you next time.
Yeah.
Goodbye.
Thank you, Dr. Chung. Did you the other thing,
I send
the
it out.
AP, the test 1 you sent? as well?
Okay, yeah, I'll send it out to you,
Okay.
okay?
Thank you so
All
much.
right, you are
Thank you,
welcome.
Dr. Chung. Have a good night.
Okay, okay, bye.
Okay, bye.